All right, welcome back. We are Game 3001 in the Winter 2020 semester at George Brown, and it's week 12, part 1 of our broadcast. We're talking about SDL animation a little bit, and I have to do this even though it's not really an AI topic. I have to do this because you're using my framework, and I've asked you to do SDL animations for your assignment number 3, and I haven't really enabled that inside of our projects. Okay, so just like you, I'm starting from a template version 8. So if I look online, I've created a lesson 10D is what I'm working with, 10D. Here, I'll come out of this and I'll show you. So here's 10D. Inside 10D, I've dropped in my 2 sprites, so Mega Man Idle and Mega Man Run. What these look like, they look like this. There's Mega Man Run, and here's Mega Man Idle. There's 4 frames of animation each. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 4 frames of animation each. It comes from a bigger sprite sheet that looks like this. Okay, with different kinds of animation. We're going to talk about problems with this, and you might see sheets like this online, and there's positives and negatives to what we can do here. Okay, but this is Mega Man, and I want to be able to animate. I've kind of extracted these little sequences from that bigger sheet, and I want to use these sequences in our little example today. Okay. Okay, great. So that's what we're doing. And how are we going to do it? Well, let's run our template. And by the way, guys, I'm also looking at you from another screen on the other side here. So if you put up a question or something like that, then I'll be able to see your questions. So please interrupt me also if I don't see you and if I'm going too fast. And if you need to ask me a question, just interrupt me and I'll stop. And just note that I am on YouTube, broadcasting on YouTube Live. So you may be captured. Your question might be captured. Just letting you know. So again, the best way to do it is just text me something, and then I'll stop periodically and look over. And if there's a problem, I'll try and help out. And I'll stay around at the end for questions, Q&A after. Okay, so yeah. So what did we have last time? So when we run this thing, when it finishes building, and I've already put this up on GitHub, and I'm going to share GitHub with you as well as the video we're making here on YouTube and all that kind of stuff. That'll all be shared with you as normal after this. So let's see when this comes up. Okay, so there we are. So it's come up, and if I press 1, you can see that right now what it does. It takes me to this other scene where I can control a little ship, and I can hop along with it, right? And that's all it does. So I want to kind of clean up my scene a little bit. So let's do that. So I'm going to go to my Solution Explorer, and I'm going to go to my level 1 scene.h, right? And in my level 1 scene.h, I'm going to remove some stuff. So I'm going to remove my ship and my tree. So I'm not going to do that this week. Remove these things. And in my level 1 scene.cpp, scrolling down, I need to remove all this. It's just remove the, kind of the lines of red that you're seeing here. And again, if you guys are trying to follow along on YouTube, as an example, you can look at a project that I've put up on GitHub to follow along with, and that is here. So github.com/George Brown College and Game 3001 Winter 2020 Lesson 10D. This is the one that I'm going to be sharing with you guys later on. Okay. All right, so I've cleaned up this level 1 scene, and now if I run it, it's going to be pretty much blank. There's nothing in this scene whatsoever. So what I want to do is I want to animate Mega Man, and I want to create a new object called player. Now I know that we used to have a player object, and we've just removed it excuse me, from game objects, but not from our project. So I want to go into my game objects folder, right? And I'm going to do that in the operating system. So I'm going to open up my folder in File Explorer. I'm going to go into src folder and look for player and just delete it. Player.cpp and player.h. You got to remove those two things in order for us to do this thing today. So just remove those two things. And we're going to make a brand new player object here. So I'm going to make a new player object. So new item. And it's going to be in the src folder. Okay. The item is going to be called player.h. Right? So that's going to be in the src folder, add. And I'm also going to immediately make a player.cpp. So again, that's player.cpp right here. Okay, again in the src folder. My player.cpp, I'm going to immediately include my player.h, just so that's done. And in my player.h, I'm going to do the same thing we always do. If not defined player, then I'm going to define player and end if. Okay. I'm going to make a new class, which is player, and it's going to extend a public display object. Resharp or C++ is saying, do you want me to include the display object.h? And the answer is yes, I do. So it's going to include it up here. In here, I'm going to have two areas, a public area and a private area. Okay. In my public area, I'm going to have a player constructor and a player destructor. And I also want to include the lifecycle functions that are part of the display object superclass. So I'm going to go here and generate missing members. So we're going to call these display object lifecycle functions. Okay. And then from here, what I want to do is I want to generate definitions by declarations, just like we normally do. This is, again, all Resharp or C++ stuff to help me out. I'm going to change my player destructor to default, like it recommends. Right, that's why it's glowing green. It says, hey, make it default. No problem. For now, that's what I'll do. All right, are you with me? Because I can do this all day long, but I don't know if you guys are with me or not. Yes, excellent. Okay. At least someone said yes. Okay, so that's great. And what I want to do now is I want to do the regular things. I want to load up my sprite, and I need to use the texture manager, and I'm going to go through the game.h to do that. Right, here's game.h. And I'm going to load up the texture manager. I'm going to say the texture manager instance load, and I'm going to decide on a friendly file name, so // assets / and again it's going to be sprites this time round, and it's going to be megaman idle.png, and the ID that I'm going to use is player idle. That's where I'm going to load into the texture manager, and the renderer of course is going to be the game instance get renderer, and that's all I need. So I'm going to load up this sprite. I'm just going to put this on another line so you guys can see it. Okay, so this is what the load function will look like now. Okay, so this loads up the sprite like normal. That's what we normally do with a player. Okay, next we want to define the frame width, and we also want to define the frame height. Right, so frame width and frame height is the width and height of each keyframe, right, in our animation. And how do I figure this out? Well, if I go to Fireworks for a second, you can see that, and this is just whatever application you want to look at it, here is the 4-frame animation for the idle sequence, or the idle cycle, right? And I want to measure the entire width. So again, if I go to modify canvas, canvas size, you can see that the total size of the canvas is 324 pixels. Yeah? So 324 pixels. So if I use a calculator, and if I say 324 pixels, and if I divide that by 4, I get a frame width. Each keyframe is 81 pixels wide. And then the height is, if I go to modify canvas, canvas size, you can see that the height is 58. So I'm just measuring it. You can also get this from the operating system instructions, but more or less it's 81 by 58. Okay, 81 by 58. So that's what I'm going to put in here. I'm going to say that I'm going to set the width to 81, and I'm going to set the height to 58. Okay, now that's kind of hard coding it, but that's what we need to do here in this case. Okay, next let's set up some stuff. We have to set the position, and the position we can put vec2 or x and y coordinates. I'm going to use x and y's. My screen is 800 by 600. I can just say it's 400 and 300 right in the middle of the screen, like we've done before. That's where I want the position of the Mega Man to appear. Next, I want to set the type, set type, and my type, there is no player type. I have a ship, but I need to change this. So I'm going to right click on the type. I just chose a random type for now, and go to definition. It's going to bring me to the enumeration, and I'm going to add in player. So that's the type, player. Okay, player type. And I can just change the type to player now, player. The other thing I want to do is colliding. So set is colliding. I want to set it to false, because by default the player is not colliding with anything. Okay. I could also set velocity, and set acceleration, but there is no velocity and acceleration to set right now, so those remain 0. Okay, and that's really my constructor. Questions around this? So you guys are with me on this one? This is just a constructor that I built for the player. Again, this is very similar to what we've done other times. Awesome, thank you. All right, so now the draw function, and this is where the challenge is. So I've built a new draw function for you guys. So let's take a look at our managers, and if I look at the texture manager.h, here's texture manager.h, I have a 5th draw function, this 5th draw frame, which is just another overloaded function of these other 4, and an animate function that is a helper function. The animate function basically chooses which frame to look at. Every frame, it kind of moves the needle. It moves like where I'm looking at from the next frame to the next frame to the next frame. This actually does the animation calculations. That's what it does. All right, and draw frame actually draws it out. Okay, so let's take a look at draw frame, this draw frame, which is new. So draw frame takes a bunch of parameters, as you can see, and I'm just going to bring them all on a different line so you can see them here. So you can see that here's all these consts. I have my frame width and frame height here, so I asked for those. So here's x and y, the friendly name of the texture, right? Current frame is the current frame that I'm at, and you can notice that is a thing, right? So one thing that I have to do differently with this one, I'm just separating them so you can see them in separate details here. So x and y coordinates, that is like my position x and my position y. Width and height, we already just defined that. Get width and get height is what we're going to use. But this is different. Current row and current frame, they take a reference to 2 variables that I need to pass in. So these variables have to exist in the player object somewhere, and they don't exist right now. Let's add them in. So I'm going to go to player.h, and at the bottom I'm going to say int m underscore current row and int m underscore current frame. Right, those 2 are the things that we're going to use. It's going to keep track of the current row and current frame of my animation. Okay, so again, if I go back there, you need to kind of pass in those things, current row and current frame. Okay, So in my player.h, I want to initialize those. So in my player.cpp, I'm going to go to my constructor, and I'm going to say m underscore current row 0, m underscore current frame 0. So let's initialize those two things here. I'm just pausing to give you guys a chance to catch up. And now I have some things I need, because I know I'm going to use that function, that texture manager function, right? So that's this stuff. Okay. Okay, now I have frame number and row number. Frame number really is how many frames per row. So in our case, we have 4 frames per row. And how many rows do we have? Right, number of rows really is what this is. So number of rows, I have only 1 row, right? And then I have some other things. I have something called the speed factor. How fast do I want my animation to run? The renderer, the angle that this is going to be drawn at. Let's just make these different lines. Angle. The alpha transparency. Is it centered or not? And do I want to flip the image? And we can use SDL render flip to help us with that. Okay, so that is the draw frame function. I pass some of these things inside the animate helper function, and the animate helper function is down below. What it does is it takes frame width and frame height. Let's look at those again. So frame width and frame height. We also have frame number and row number. We take that information in, as well as the speed factor that I pass in, right? And the current frame, I pass in the current frame and current row. All this stuff gets passed in from the previous function, right? I calculate the total frames. I say, okay, let's see how many frames I have completely. If I have 2 rows of 4, as an example, then I would say frame number is 4 and row number is 2. Like, how many rows do I have? How many frames do I have? So 2 times 4, that's 8 total frames. And when I want to select my animation rate, how fast I animate, right? I'm going to take the total frames, so that's like 8 divided by 2, 4 divided by the speed factor. So by default, the speed factor is 1, so there will be like 4 frames of animation. The animation rate will be 4. So then I get the total frame count. I get the frames that I'm getting from the game. The game actually counts frames. 1, 2, 3, 4, 10, 100, 1,000, whatever it is. I take whatever that current frame is, divide it by the animation rate. It gives me a remainder, and if the remainder is 0, which means, for example, if it's 4, every 4 frames, right? Every 4 frames, it'll do this. It'll move the needle more or less. It'll look in different places on the texture every 4 frames. That's what this does. However, we have a flaw here, okay, that I detected earlier. And the flaw that I have, I just want to let you know this, is that it cannot handle a single frame. Like if it's a single frame animation, it won't handle it at all. Why? Let's take a look. So let's suppose my total frames is 1. So my row number is 1. 1 times 1 is 1. Yeah? Okay. That's okay. And then I say, okay, I want to take for my animation rate, I want to take my total frames divided by 2, 0.5, divided by the speed factor, it's still 0.5, and then round it. This rounding reduces it to 0. So my animation rate becomes 0, and then I'm trying to divide by 0 to see if there's no remainder. I'm going to get a division by 0 error here. So instead of that, I need to check to see if at least I have 1 frame. So if I have greater than 1 frames, if total frames, right, is greater than 1, so I have more than 1 frame, then I want to do all this work. Otherwise, just ignore. Okay? And that's the only change I want to make to my animate helper function, right? The helper function was good, but there was an error. There was a flaw that I noticed earlier. Okay? Any questions around this? Are you guys good? All right, so excellent. Thank you, Megan. So as we move on then, right, we have this working now, and I understand how the draw frame function works, right? I need all these things. So now let's make it work for the player.cpp. So in my player.cpp, I'm going to go to my draw function where all the drawing happens, and I'm going to call in the texture manager. I'm going to say, hey, that texture manager, right? Instance, I want to draw frame, and I want to draw frame the last one. I want to use the last one that I want to use, right? So the first part of that is a friendly name that I want to draw, which is player idle. That's the one I want. Okay, and then it's the x and y coordinates. It's get position dot x and get position dot y. That's the x and y coordinates, right? And then after the x and y coordinates, I want the frame width and frame height. Well, that's just get width and get height. Okay, that's what that is. And then get width and get height. You know what? I'll put that on different rows so you can see it. I know it's gonna be bigger, like kind of like taller up here, but who cares? As long as you can see the stuff, I'm good. So get width and get height, and then my current row, I pass in m underscore current row, and my current frame m underscore current frame. There we go. And then my frame number, how many frames do I have per row? So right now I only have 4 frames per row, and there's only 1 row, right? My speed factor is 1.0f, right? And then my SDL render is the game instance get renderer. That's where that comes from. I can define an angle. So my angle is going to be 0. My alpha transparency is going to be 255, which is 100%. And am I center or not? The answer is true. So I'm going to put all that in there. And let's just move these frames down to the next line too. So this is what it looks like. So, I mean, again, I've just broken it down into a few lines. This is actually one big line. That's what this is. But instead of me making it one big line, I've just broken it down so you can see everything here. We also got the name of the of everything here. Resharp or C++ gives me all this stuff. And this makes the line even longer, right? So just letting you know. It appears in our editor even longer. So this is what's going to draw my player. And I'm going to try drawing him with only 1 frame. So I'm going to change the frame number to 1 so I can only see 1 frame of animation at a time. Just for now. So we can test out that problem that we had. Are we good with this one? Because I'm going to move on now. Excellent. Thank you. All right, so now that we've got our player CPP and our player.h figured out for now, I want to go to my level 1 scene.h and include it. So I'm going to go, here's my level 1 scene. Let's include my player. Include player.h. Excellent. I also want to make a new player pointer, m underscore p player, with my player pointer, right? And what I'm going to do is in my level 1 scene.cpp, down at the bottom where my start function is, I'm going to say that m underscore p player, right, is equal to a new player. I'm going to allocate some space on the heap for it, and I'm going to add my player to the display list, m underscore p player, which we've done before, all right? Because my display list is actually functional now. If you look at just like we've done last time we were together, I have a draw display list and an update display list, which actually updates everything that I've loaded into the display list. So it does. I just have to do add child and we're good to go. Okay? If that makes sense. So now if everything's good, I should be able to run this thing and see a single frame of animation with no motion at all for my Mega Man idle animation. Let's take a look. And as it's building, hopefully you guys have all this at this point. All right, let's take a look. So here's my single frame of animation. Yay, it's so exciting. However, we should probably check to see, if this makes any sense. What if, like I said before, I went back to my texture manager and inside of that animate function to test it out, let's say I just left it the way it was, which is if total frames is greater than 0. That's how it was before, right? What will it do now? Let's test to see if I'm right about this division by 0 error. If I didn't have this line, this check, So if I ran it now, and if I only have one single frame of animation, and if I go to my scene, you can see now that it craps out and it says integer division by 0, exactly like I thought it was going to do. Okay? So let's put that back. That's why we did this. That's why we did this animation. We changed the animate function a little bit, because I saw that flaw. Okay, well, we've tested one animation frame. What about if we want to test multiple frames? So again, I'm going to go to my player.cpp and change the frame number in the draw function to 4, which is what we have. We have 4 frames in one row, right? Again, let's take a look at that fireworks stuff. We have 4 frames, 1, 2, 3 keyframes, and 1 row, right? And all we're going to do is we're going to go 1 frame at a time. Yeah, I love when I have there's a fire in my house. No, I'm joking. People are cooking and they're cooking. They don't put the fan on the stove. That's what happens. Lots of smoke. Awesome. Okay, so 4 frames, 1 row, and let's see what that does. Now this is going to be too fast, and you're going to notice when I run this thing, Mega Man is going to appear like he's on steroids. He's going to run like crazy. I mean, he's going to like be idling like crazy. Let's take a look. Right, so it's pretty fast, like too fast, right, for the idle animation to happen, right? So we can slow it down, and we can do that by the speed factor. So I can reduce the speed factor, and I've played with this. If I reduce the speed factor to something like 0.12, which is like 12% of the default animation rate that we decided on, and if I run it, then we can see that if I run it again, you have a decent kind of animation. It's not as bad as what we saw earlier. Okay, it's pretty good. All right, cool. So we have our draw frame animation, and the animation is just the player idle. Are you with me? So hopefully you're with me. Excellent. Okay, so the challenge. Here's the challenge for you guys, right? Can we shift from one animation state, player idle, to player run? Can we shift to that? What do we need to do? Well, first we have to define some animation states. So I'm going to go into my Solution Explorer in my enums and make a brand new enumeration. Okay, so here's my new enumeration. I'm going to put it inside my .h. We're going to call this player animation state. Player animation state .h, player animation state .h, and put it in the src folder. I'm going to add that in. But before we continue, this is where it's empty, player animation state, right? I'm going to go to my Team Explorer, and I'm going to put this up on GitHub, because basically we've made it animate for the first time. So this is all this stuff. I'm going to say that, and by the way, if you notice here, I can stage all, which is, I've added everything to the staging area. And here what I'm going to just add a little comment, right? A little commit message, which is going to be like added frame-based animation, for Mega Man, right? That's what we did. Or maybe my player, for player idle. That's what we did. So commit staged, and then home, sync, and push. And that will push everything up to the up online to less than 10D. Okay, and to check this, just to see that everything is working, if I refresh the screen, you can see now that I have 2 commits, and that's exactly what I'm. The same commit is what's happening right now. Okay. Again, I'm trying to remember to do this because we need to add. We need to do more commits here. Okay, so if not defined, then again it's called player animation state. Pretty big a long one, right? Let's define it. Player animation state. There we go. And then end if defined. Okay. So it's the same pattern we've always used. We're going to make a new enum, right, which we're going to call player animation state. Okay. give some separation there, just some white space so we can see it better. And then the first state is player idle. And the second state is player run. And something like number of animation states. We don't know how many there are, but we want to keep track of how many animation states there are. Idle, run. So now that we have this structure, right, then what I can do is I can pass that into the player.h. Let's pass it in. Player animation state. And I can make a variable to hold that. I can say that player animation state is m underscore current animation state. Current animation state. And I want to initialize this in the constructor function. So I'm going to go to player.cpp in the constructor function and initialize that too. I'm going to say m underscore current animation state by default is player idle. Okay, that's the default animation state. Okay, so I've done that in the constructor function. There we go. And what I want to do is I want to make a switch case. I want to switch, depending on what I'm doing, if my state, what does it tell me? Enum type player animation state is unscoped player enum class over enum. Yeah, prefer it. I'm not going to use enum class right now. Okay, so here I can make a little switch case under m underscore current animation state. And I can define a couple of cases. The first case is, well, we already said it, player idle. And the second case that we have so far is player run. Okay, well, we know the first case. The first case is this. That's the first case. Player idle. All right, play the player idle animation. How about the player run animation? Well, in order for us to get this, there's a couple steps. One is we need to load another texture. And as soon as I tell you this, in your mind you should say, uh-oh, alarm bells. Is there a better way to do this? And there might be. Player run. Megaman run. Okay, that's the one thing we have to change. So this is my second sprite sheet. First sprite sheet, the first strip is this Megaman idle. And the second strip is Megaman run, which is Megaman idle and Megaman run. Two different sheets. Okay, so we're loading two different times. Great. And then inside of my player idle animation, we can simply just copy this and change this to player run. But I'll tell you right now that the animation at 0.125 is too slow. You'll see this in a second. I'll leave it there for now. But we'll talk about it. So that's all this information copied. The exact same stuff, except for the player idle goes to player run. Wouldn't it be nice if we can encapsulate all this other stuff and all I have to pass in is player idle and player run? That'd be the best. But there's issues with that. There's stuff, right? There's things we have to define. So, but it would be nice if we could do something simple like that. Okay, cool. So, so that's one. Now, how do we trigger the change from player idle to player run? Well, that happens inside of my level 1 scene. First of all, can I move on from this? Are you guys good with this? Excellent. Okay, so let's go to my level 1 scene. .cpp. All right, so level 1 scene, I have a couple of key presses I can do, right? I have a WASD. This is inside of the handle events function. You can get there by just going to handle events like this, right? So my handle events function has these key downs, right? I can do an escape key, a 1 key, a 2 key. I've commented those out for now. But I can also do these movement keys, WASD. I don't really care about moving up or down, so W and S. So I'm just going to package those off together for now. And since we're not going to use them, these are kind of unused. And there's a couple of things we can do here. We should probably comment them out because they're going to be conditional statements. So I'm just going to say let's not use these ones, right, for W and S. All we care about is the A and D keys, right? So the way it's going to work is the D key for now. If I press the D key, then M_P player, I'm going to, oh, well, I can't do this. I have to have some other kind of setter to set the animation state, right? So going back to the player, I need to make a new setter. And the one I need to make is set animation state, which I'm going to get this new player animation state, right? This set animation state is what I want to do. Let's just implement this. And set animation state, what it's going to do is I'm going to say M_current animation state is going to be equal to the new state, whatever that is. And let's make that a const, like it's suggesting. Okay, awesome. So that's what we need, this current animation state. We can set the current animation state by having a setter, which we've defined in player.h. Okay. So going back to CPP then, we would say that I want to set animation state to the new state, which is player run. So whenever I press the D key, we're going to player run. Okay, but the problem is it's going to always run forever. And I want to stop it when I stop pressing the D key. So for this, we need to change some of this stuff. So right now we have this, on line 48, we have this key pressed. This is inside the level 1 scene.cpp. We have this key press variable that assigns stuff to event.key.keysim.sim. And that's great, but if I add another variable like that inside my switch case, it's going to complain. So instead, I'm going to go up here to the top and add in two variables. One that is of type SDL key code. We're going to call this key pressed. And we're going to do another one, SDL key code. And it's going to be key released, because we're going to be able to release our key too, right? So key released and key pressed as we want in there. Those are a couple variables. So key pressed is this one, the key pressed variable. And we want a key released variable that does the exact same thing this does. So I'm just going to copy this line so we don't have to type it. And then what I want is, we have an SDL key down case. I want an SDL key up case. So at the end of the break here on line 90, I want to add a new case, switch case. So it's going to be case SDL key up, right? And what I want in here is to define this new key released. Key released is equal to this event.key.keysim. And when I release the D key, I'm just going to put these both in there for now. When I release the D key, right, I want a key released event. Key released. Key released. And when I release the D key, it's going to go back to run or to idle. Okay? So again, this does the run animation. When I key press it, when I release it, it's going to go back to idle. Are you with me? Sorry guys, I gotta keep checking on you because there's a bit of a delay between what I'm typing and what I'm showing you. All right, so hopefully you guys are good with this. All right, so now that this is true, let's test it and see if it works. So I'm gonna run it, and if we did everything correctly, we should see Mega Man move from an idle state into his run state. Let's do this together. As I'm building. All right, built. And there's a bit of a delay between what I'm showing here and what you're seeing, so I'm going to wait until you guys can see what I'm doing. Yeah, that's almost a full second of delay. So I want to make sure you guys see it. So what I'm seeing now is my animation goes like this. You can see that the animation is still the same. So here's my Mega Man animation. I'm just waiting for it to show up on your screen. There we go. And if I press the D key, I can start running, but it really runs slowly, like super, super duper slow, right? So like I said before, what I want to do instead of running this slow is I want to run faster. So I'm going to go to the player.cpp here. And where the animation from my player run shows 0.12, I'm going to change it to 0.25. Okay, so that's what I've done here. I've just changed it to this part right here. Okay, does that make sense? Because if I don't change it to 0.125 or to 0.25, it's going to be too slow. It's going to be way too slow. Okay, so if I run this again, let's run it again now, after I've changed it. And if I press the key, you can see now that he's idling okay. And when I run, he's running a little bit faster, right? He's not terrible when I'm running. Okay? Now here's the thing. Wouldn't it be nice if I can run the other direction? I mean, it makes sense, right? And that's kind of how I've set things up for you guys. So I can run in any direction I want. And the way to do that would be to have more states. So I'm going to add more states in. And I'm going to rename this state. So right now my player idle is the first state. So I'm going to rename this one. So from player idle, we're going to call it player idle right. And from player run, we're going to right click and refactor rename to player run right. So 2 states. And I'm going to add 2 more states. Player idle left and player run left. Okay, so player idle, player run. Okay. Does that make sense? So this is where I wanted to change. And if I've got these, then inside my player.cpp, where I have these states, these cases, let's add 2 more. So I'm going to add another one that's case player idle left. If I can spell player, right? And let's also add another case for player run left. So I can run either way. Okay? But how do I code this now, right? Well, it's the exact same. So I just take this part here and copy it to the player idle left. It's the exact same thing. The only thing is I need to add in another parameter down here in my draw function, which is SDL flip horizontal, right? And what this does is it'll flip the texture for me with using SDL to flip it to the left. And since we can do that here, we can do the same thing down here. And you can see that for the most part, we're just duplicating some of this stuff. We're using the state machine very basically. So this is SDL flip horizontal. Okay. So that does 4 states. So right, idle left, run right, run left. And the only thing we've changed is the SDL flip horizontal, and we added 2 more states. Okay, cool. So now that we have this, we have to change our level1.cpp. So going back to level1.cpp, we have our D button. Let's make our A button work. So copy this into the A button, make this run left. Okay, that's the animation. Same thing goes with our, when I let the key go, the A key, I want to idle left too, right? Because if we're already going left, I don't want to look right. I want to have 2 states, left and right. Okay, cool. So I've got all that. And now let's see if we can run this. And if everything goes well, we should be able to run to the right, idle to the right, run to the left, idle to the left. So again, 4 animation states with a state machine. All right, let's talk about this. So again, I can run to the right, right? If I stop running, I can run to the left, right? I can stop running. I can switch right and left, and it looks pretty good. Okay? I can switch right and left. There we go. There's my switch right and left. Any questions around this? So again, I think there's some really good stuff that's happened here, but we have some limitations. We do have some limitations. And does anyone have an idea of what limitations we'll have? Let me put this up on GitHub. So Team Explorer, I'm going to go to Home. I'm going to go to Changes. I'm going to say Added. I'm going to call it Player Run Animation. Right? I commit all. And I'll go to Home, Sync, and Push. Okay, Home, Sync, and Push. There we go. All right, so that's up on GitHub. So what are the limitations for this one? Can anyone think of a limitation at all? There are limitations. Here's an example. What if, instead of having this sprite sheet, I actually had this sprite sheet, right? Let's see what you guys think of this one. When you guys get it, right now it's kind of slow. There we go. So instead of that one, I have this one. Okay, so what do you think of this? But do you think there's limitations now? Because, see, this is how you normally get them. You get them like this. So here's the problem with this one, right? You can see on this one that there's different sizes of, or different spacing between the sprites. So notice on row 3, what you have is some sprites are closer together than row 1. It's not like they're evenly spaced or anything. Like row 3 is a problem. There's a lot of sprites that are very close together. Even row 2 is a problem. If you notice near the end where there's a death animation there, and it looks like there's like 4 frames of death animation that we're showing here, right? These 4 frames of death animation, as an example, for these 4 frames, they're offset. The bottom and the top are different. I've got the character that's lying on its side, that's way over here on the other side. It's quite slow, right? So you can see that is going to be a real problem. Okay. So how do we deal with something that looks like this? Okay. Well, it would be nice if we were able to not worry in any way about the order of my frames, my keyframes on the sprite sheet. I don't want to worry about the order. I want to take any of the keyframes and I want to construct my own little sequence from these keyframes somehow. But that's a totally different thing. I need a new construct. I need something like a frame struct. The frame struct is going to have the name of the frame, the X and Y coordinates, where it starts on the sprite sheet, as well as the width and the height. I need those things, right? And then I also need some kind of animation class that allows me to play or record an animation, right? So I can say I want my run animation, as an example, to be frames. And if I was counting normally, if this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is frame 8, let's say the one on the second row, right? I'm just going to wait till your screen updates so I can show you what I'm talking about. Because your screen is way slower than mine, like a good 2 seconds slower right now at this point, right? There, my mouse pointer is going to that one. So the second row, that's frame 8. So if that's frame 8, that's the next one is frame 9, 10, and 11. So if I could say, you know what, my idle animation is frame 8, 9, 10, and 11, if that's what I can do with this stuff, that would be awesome, right? As opposed to, you know, I have to choose that line, I have to separate this out, cut it out, make its own sprite sheets and all this kind of stuff. It might be easier. That's one thing. So from an animation perspective, it'll give me more leeway. And the other thing that might help also is when I load up tile maps, right? So if I go up online here for a second, and if I look at some tile maps, so let's look at tile map, right? 32 by 32. So I want to look at a 32 by 32 tile map, right? An example of it would be this. Here's a 32 by 32 tile map, right? This one. And I want to make a background that looks like this. I don't want to load up each of these tiles separately. That doesn't make any sense, right? I want to have a big sprite sheet. I want to be able to cut this sprite sheet into tiles, right? And because how orderly it is, I want to choose whichever one I want. So if I want to choose, let's say, on the corner here, this this part of the structure, which looks like a wall, then I should be able to do that. I should choose anything I want from here and construct my, my background with that in mind. Okay. So this requires a whole different way of doing things than what we're doing right now. Right now, we're very simplistic. I load up a texture. I go from one frame to the next frame. Everything is evenly spaced, right? And I use a for loop, basically. All I'm doing is I'm looping through each of the objects from one position to the next, and I'm just moving where I'm looking. The source, I'm moving the source of my of what SDL is looking at to a new place, a new place, a new place, but it's equally matched. I can do the same thing without it being, evenly separated, but anywhere on the sprite sheet that I know, right? So what I need is some kind of sprite sheet descriptor, right? Something like that. And in order for us to have that, we can do two ways. One, we can manually go into the sprite sheet and then decide on the positions of everything. So example, if I was to go back to here into my Mega Man sprite sheet, I could manually go in here, right? And then take a look at the X and Y positions of when everything starts, as an example, and then the width and the height of each frame. Okay, I could do that. And then write them down somehow or record them on a text file. I could do that. That would be a lot of manual work, but it's totally possible, totally doable. No tool required. Okay? And then what I would do is I would load that text file through file IO. I would have to file input and output. I'm going to read the text file and somehow understand what each of those things that I'm reading is. I'm going to serialize my text file when I output it. Serialize means I'm going to put it in the right order. It's going to say the name of the sprite and the X and Y coordinates, as well as the width and the height of each sprite, each frame, basically. I'm going to output. That's how I'm going to serialize everything. So every line is going to be a different sprite. Okay? And then I'm going to deserialize things. I'm going to load things back in, and I'm going to create frames, a frame structure for each of these sprites that I'm going to hold in memory somewhere. Okay, that's what I'm going to do, which is actually going to be in my texture manager. That's what I'm going to do for this. Okay, and once I've done that, once I've created these frames, right? I've loaded it up and I've kind of put together these frames. I want a class, some way of navigating or collecting some of these frames into a sequence, a cycle, right? So if I want to do like an idle sequence, I can go from frame 8 to frame 9, 10, 11, that kind of thing. Okay. So that's what I want to do. Okay. But this is going to require more than an hour of work that we have together right now. And it's going to require another tool. So the tool that I'm going to be using is something called Texture Packer. And I'm going to show you what this looks like. You can get it. It's not a free download. It's something that you have to buy, right? Now, if you're going to be doing 2D graphics and any kind of 2D games or even UI elements and stuff like that, if that's going to be your role and you're going to be working with this stuff over and over again, then Texture Packer is for you. It works on both mobile and mobile platforms as well as desktop platforms, right? They have a lot of presets for different platforms on Texture Packer, so you can export for a particular file format that that's required, or you can make your own. And this is what I'm going to do. I'm going to make my own little format. I'm going to do all the work for you. I'm going to make my own little format with Texture Packer. It's going to output a text file exactly the way I want. It's going to serialize my text file properly. And then all I have to do is drag and drop my sprites into here, and I can press publish. And what this is going to do is going to publish two things. A sprite sheet that's in the order that I want, and it's also going to publish a file descriptor, a data file, that's going to tell me where everything is, that text file that I'm talking about. Okay, so that's what this little tool is going to help me do. All right. Now again, I can do it all manually. If you don't have access to the tool or whatever, it doesn't matter. You can literally go into the sprite sheet and measure things on your own and just write them down inside of a text file. Or you can hard code them inside of your program. I don't recommend that though. All right, so then once we have that text file, let's say as an example, so we have let's say we have a text file for this. We're going to have it should work with this as well. If I want to make it work with this sprite sheet, then it should work. And if I want to make it work with this sprite sheet, it should work. And if I want to make it work for this sprite sheet over here, it should work as well. It should work for all those cases, right? Whichever one I want. So whether I want to animate a single sprite, multiple sprites, or I want a tile map, it should be able to load up everything, and I should be able to construct my my structure any way I like. Okay, put together everything. So that's really the thing that I want to do, and that's going to be something I'm working on already. I've been working on it for a couple days, and what I'm going to do is hopefully by next week I'll have the structure out to you. No work for you to be done, so that way you have this. Now for assignment 3, what I'd like you guys to do is work with the structure I've given you, so you can do some simple animations like this. You'll have to have different animation strips for your animations. So again, you might have an idle animation strip, you might have a run animation strip, and so on, and you might have other ones. And there's other animations out there, other characters that you can look at that actually show you characters in different directions, right? So you might have some characters, and I'm going to show you one that's Lex. Here's one, and this sprite sheet here. I'm just going to zoom in for a second. I'm just randomly choosing stuff. But you can see that this sprite sheet has 8 characters, and each character has 4 rows of animation, and it's moving the character, or appears to animate the character, in different directions. So this is moving down, this is moving up, this is moving to the right, this is moving to the left, and there's 8 different characters here. So this is the thing. How do you do something that looks like this? Well, with our current framework, it doesn't work. But with the new thing that we're going to build, this can totally work, right? So that's what we're working on. We're working towards giving you flexibility, so that way you can create, you can have whatever you like. Now in this case, luckily these are all evenly spaced, so this wouldn't be totally difficult for us to slice up, as an example, and put it inside of Texture Packer. Texture Packer can take care of a lot of this for us, right? And I'll show you how to use Texture Packer next week. But for now, that's all I wanted to show you this week. It's a really short one. Please work on your assignment number 3. If you, again, I recommend you start. If you haven't started already, you should start. I know some people have been kind of delayed because of the the coronavirus thing and everything else that's going on right now, and that's totally understandable, guys. But I think what we need to do is what I'd ask you guys to do is kind of work as much as possible on trying to get this going. Okay, so I'm going to stop recording now just for a second, but I'll take your questions.